Hey students, today's lesson is on rational numbers. So to start with, let's look at some key vocabulary. A rational number is a number that can be written as a fraction, a over b, where a and b are integers and b is not equal to 0. So rational number has this root ratio in it. Oops, let me see if I can get my pen going here. Ratio. And a ratio is written with fractions, so there's sort of some key ideas in there. A and b can be any integers, positive or negative, except that b cannot be equal to 0 because we can't divide by 0. Okay, so negative 1 over 2 is a ratio, negative 15 over negative 27 is a rational number. So we have a wide variety of rational numbers as long as we have both an integer on the top and the bottom. A terminating decimal is a decimal that ends. So for example, 0.1 would be a terminating decimal. It terminates after just one digit. 0.25 is a terminating decimal. It terminates after 2 digits. We could have a longer one like 3.7652219. That's also a terminating decimal if that's all of that there is to that decimal. If it ends after the 9, it terminates or stops. A repeating decimal is a decimal that has a pattern that repeats. So we might see 1/3 is 0.3 repeating, meaning 0.33333333, and those 3's just keep repeating forever. We could have a decimal that repeats a couple digits, like 0.17 repeating. That would be 0.17171717. Okay, so that would be a repeating decimal. Let's go ahead and look at some rational numbers and how we can write them as decimals. So here we have negative 2 1/4. So most of us probably are pretty familiar with the fraction 1/4, and we know that 1/4 is 0.25, which would make this decimal negative 2.25. Now, if we didn't know that 1/4 was 0.25, we can look at this 1/4 as 1 divided by 4. So we can set it up as 1 divided by 4, and 4 doesn't go into 1 at all. So we'll change this to 1.0. 4, we'll put the decimal right up here. 4 goes into 10 2 times. 2 times 4 is 8. We have 2 left over. We'll need to add another 0 and bring it down. 4 goes into 25 times. So we can prove this, that 1/4 is 0.25. So negative 2 1/4 is negative 2.25. 5/11ths, we probably don't know what this is as a decimal until we do the division. So we're going to do 5 divided by 11. 11 doesn't go into 5, which makes sense because 5/11ths is a fraction less than 1. We can tell that it's 0 point something. So now we'll see how many times 11 goes into 50. See, 11 times 4 is 44. 11 times 4, 44. We have 6 left over. Now we have 11 goes into 65 times, because 5 times 11 is 55. Now we'll subtract. Okay, so now we're back here to 50. So 11 went into 50 4 times here, and then we ended up having 60, and 11 went into 65 times. We're going to see the same pattern, that 11 goes into 50 4 times yet again. 4 times 11 is 44. And now we're back to the 60, and it's 5. This is going to keep on repeating over and over and over again. We're not going to keep doing it, but we can write this as a decimal, 0.45 repeating, and this bar goes over both the 4 and the 5 to show it's both digits that keep repeating over and over again. Now we have an example where we're writing a decimal as a fraction. For most of us, this is actually a little bit easier. 0.26, the correct way to read that is negative 26 hundredths, right? This is in the hundredths place. So we can write negative 26 over 100. And sometimes it's as simple as that. In this case, we're going to need to simplify a little bit. I can see right away that both the top and the bottom are even numbers, divisible by 2. So we can simplify this to negative 13 over 50. 13 itself is a prime number and it doesn't go into 50, so that's as far as we can go. Negative 13 fiftieths is the same as negative 26 hundredths. All right, and then let's look at this last example where we're ordering rational numbers. Here we have the elevations of 4 sea creatures relative to sea level. You can see that they're all negative numbers, negative rational numbers, and they're negative because they're underneath the sea, right? They're sea creatures that live underneath the water. But we want to see which ones are deeper than a whale. So let's start with the whale, since that's our reference point. Negative 0.8, so here's the whale. And then let me use a different color for the other 3. So we're going to rewrite each rational number as a decimal. So the anglerfish is negative 13 tenths. Might help us to start by writing this as a mixed number, negative 1 and 3 tenths. And 3 tenths is the same as 0.3, so this is negative, here. All right, negative 1.3. So that's going to be right about here, between negative 1.2 and negative 1.4. And I've got this squid is at negative 2 1/5. Let's see, 1/5 is the same as 2 tenths. So that would be negative 2.2. 2 and 2 tenths. So that's going to be right here. And then I've got my shark is at negative 2/11. I'm going to have to do some division here. 2 divided by 11. And I'll change this to 20 and put my decimal here. 11 goes into 20 one time. Subtract 20 minus 11 to get 9. 11 goes into 98 times. Move this down a little bit. 8 times 11 is 88. And I have 2. And now I'm back where I started with my 20. So this is going to keep on repeating. This is negative 0.18 repeating. So let's see, that would be about, I kind of covered it up, negative, it's a little bit to the right of negative 0.2, so it's about right here. So if we want to know which sea creatures are deeper than the whale, it would be the anglerfish and the squid. All right, so go ahead and try a few on your own, and I'll see you soon.